Hello, my name is Steve Bowler, and in this video I'm going to be configuring EIGRP Summarization. We're also going to take a look at EIGRP Leak-maps, and I'm also going to show you guys how to inject a default route into the EIGRP domain using the IP summary address command. Okay, so right now all of our routers have been started in this lab. We have 4 loopbacks, loopback 0 through 3. In this lab, R1 is going to be the hub, and R2 and R3 are going to be the spoke routers. Router 2 is connected to router 1 via the serial link. And then router 3 is connected to router 1 via a frame relay connection. This frame relay connection is going to be a point-to-point sub interface connection between router 1 and router 3. And I'm going to be showing you how to configure an EIGRP leak map between router 1 and 3. And I'm going to show you guys of how to overcome some of the problems that you might have when you're trying to configure EIGRP across these 2 routers. So let's go ahead and get the routers started. Our console into our routers, they are already started. So now that we've consoled into all of the routers, on router 1, if I do a show IP route, you can see there's nothing in the routing table yet. It looks like we have to do our IP addressing now. Serial 00 on router 1 is connected to router 2, so we'll go under interface serial 00. We'll give it the IP address 172.16.12.1 with the, let's look at our, let's make those just /24s. We'll do a no shut on the interface. Let's go ahead and change this so we don't confuse ourselves. Again, on both of these links, we'll just make them /24s. Back to router 1. Let's go to router 2 now. We'll go under interface serial 00. We'll give it the IP address 172.16.12.2. We will do a no shut. And then what we're going to do real fast on router 2, we're going to configure EIGRP. We'll do this on the, we will go and do under global configuration mode, we will do router EIGRP 1. We will put in the no auto summary command so that we do not summarize at classful network boundaries. Also, the next command we're going to do is advertise our networks into EIGRP. In this, on router 2, we're just going to put in our serial 00 interface for now. And we're going to do that with the network statement. So we're going to put in network 172.16.12.2 with a 0.0.0.0. So in this case, this is what you call the host mask, and EIGRP will only be running on this. The process will only be running on a interface that has this IP address. So let's go back to router 1 and configure EIGRP for autonomous system number 1. First command is we're going to do no auto summary, and then we're going to follow it up with the network 172.16.12.1 with all zeros. We will do the command show IP EIGRP neighbors, and as you can see, we have a neighbor adjacency already with router 2, which is 12.2. So the next step we want to do is look at our link to router 3. And what I'm going to show you here is when you summarize under point-to-point sub-interfaces, you can run into some problems within EIGRP. So in this case, we're going to show you guys how to avoid that problem by using a leak map in EIGRP. We'll go under interface serial 01 on R1. We have to specify frame relay encapsulation, and we will go into sub-interface, which is interface serial 0/0.13, which signifies our link from router 1 to 3. Sorry about that, had to change that to 01. And then under here we're going to do the IP address of 172.16.13.1 with the /24. We'll do the frame relay command for the point-to-point sub-interface. We'll do frame relay interface delc, and then our delc in this command is going to be 103. And before we exit, let's go under EIGRP, and we're going to send EIGRP hellos out 172.16.13.1, which is the interface to router 3, or the IP address that connects router 1 to router 3. So now if we go to router 3, we are using interface serial 00 to reach router 1. We'll do the encapsulation frame relay command. Then we will do the interface serial 00.31 point-to-point interface. We'll give it the IP address of 13.3 with the /24 subnet mask. And then the delc to reach router 1. We're going to be using delc 301 on router 3 to reach router 1. Let's go ahead and do a no shut on the serial interface. Let's make sure we do that on router 1. As we can see, it's still down, so let's go under serial 01 and we'll do a no shut. Now if I do a show frame relay map on router 1, we show the status is deleted. So let's give it a minute to converge. Let's go to router 3 and do a show frame relay map, and we see the same thing. So let's give it a minute. We can see that the link is showing down, the status is down, and the protocol is down. On both routers, router 1 and 3, we are having this problem. Let's go ahead and try to ping router 1 from router 3. You can see that we are not successful. Looks like our last reply was. So now it looks like we have connectivity from router 3 to router 1. Let's do a show frame relay map command again. Now you can see that the point-to-point delc is configured and is defined as active now. So the frame relay network is now up. So the next thing I'm going to show you is how to perform EIGRP summarization. Again, in EIGRP, it is very important to remember that we can summarize on a per interface basis, unlike in OSPF where we have to summarize our routes on the ABR router. In EIGRP, we can summarize on a link by link basis. So we're going to configure in this lab, we're going to have router 1 perform summarization on both of its links, which are the links to router 2 and router 3. We have 4 loopbacks, 192.168.0 through 192.168.3, all /24s. So we're going to summarize all these into a /22. First, we're going to advertise these loopbacks into EIGRP on router 1. We'll do this with the network command 192.168.0.0, and then our subnet mask, which is 255.255.252.0, which is the equivalent to a /22. So with this command on router 1, it's going to advertise this network out to all of its EIGRP neighbors. If I go to router 2 and do a show IP route EIGRP, but now what you can see is we only see the link between router 1 and router 3. If we go to router 1, let's do a show IP protocols. Oh, you know what? We forgot to configure our loopbacks. So I just paused the video real fast and I went ahead and configured the loopbacks 0 through 3. So that is the reason why we did not see those networks on router 2. So now if I do a show IP route EIGRP on router 2, we are seeing the 4 192.168 networks from router 1. So let's go to router 3 and verify that as well. If I do a show IP route EIGRP, you can see on router 3 we do not have any EIGRP networks yet. If I do a show IP protocols on router 3, it looks like I forgot to configure EIGRP on router 3. So let's go ahead and do router EIGRP for autonomous system number 1. We'll do the command no auto summary. We'll advertise the network 172.16.13.3 with all zeros into EIGRP. And what we should see is, if I do a show IP EIGRP neighbors, we have just formed a neighbor adjacency with router 1. So if I do a show IP route EIGRP, you can see now I have the 4 loopback interface networks advertised from router 1 to router 3. So now what I'm going to show you how to do is some EIGRP summarization. First, we're going to summarize our 4 loopback interfaces to router 2. So on router 1, we do this by going under the interface. Again, summarization in EIGRP is configured on a per interface basis. So we'll go under interface serial 00, which is the connection to router 2, and we'll use the command IP summary address command. Then we're going to use EIGRP because that is our routing protocol, and the AS number is going to be 1, and then we're going to put in our summary address, which is 192.168.0.0 with the /22 subnet mask, which is 255.255.252.0. What summarization is going to allow us to do is going to minimize the routing table and all of the information that goes across our network. So that way, instead of sending 4 routes to router 2, we're sending 1 summary route. This will in turn minimize the packets throughout the network and also minimize our CPU utilization on the routers, as they don't have to calculate in the routing table all of the more specific routes, all the /24s. So I'm going to go ahead and hit enter there, and if I go under router 2, if I do a show IP route EIGRP, so now instead of 4 /24s I have 1 /22. If I do a ping 192.168, if I try to ping one of the /24 subnets, we are successful to the 3 network, the 2 network, the 1 network, and the 0 network. So that is how you perform basic EIGRP summarization. It is pretty simple. What I'm going to show you next is where we actually might run into a task to perform summarization in EIGRP, but they also want you to send a more specific route other than a /22. Say they want us to send the 192.168.2 network along with the /22, but they don't want us to send the 1, the 0, or the 3 network. What we can use in this case is called a leak map. And what we're going to use the leak map for is to send more specific subnets in addition to our summary route that we're sending. What we want to do first when configuring a leak map, in this case, what we are going to do, we're going to configure an ACL. Just a standard ACL, we'll call R1 to R2. Leak. And then we're going to put in the command permit 192.168.2.0 network, the /24 wildcard bit mask. And the next thing we're going to do is create a route map on router 1, which is going to be called R1 to R2. And what we're going to do is we're going to match the ACL in which we just created. We're going to do that with the command match IP address. Then we're going to highlight the access control list and copy that into there. And that's all we need to do under the route map. So we're going to use the leak map that we just created. We just created a route map which is going to call the ACL R1 to R2 leak, which is permitting the 2 network. This is permitting the 2 network from being advertised. So what we do to configure the leak map is we're going to go under the interface serial 00 which is the interface to router 2, we're going to take off the summary address command that we had before, and now we'll do the command IP summary address EIGRP 192.168.0.0 with the /22. So we're still going to specify our summary route, but if we do a question mark on the end of this, you can see that we have an option to specify the leak map, which will, in this case, we're going to specify our route map, and then the route map is going to call on the ACL that we just created, which permits the 2 network. So we'll put in leak map, and then it's going to ask us for a word for the leak map, which is going to be the same thing as the route map name. So we'll put the route map name under there, and then we'll hit enter. Now if we go back to router 2, what we should see in the routing table, if we do a show IP route EIGRP, we should see the /22, and we also should see the more specific route, the .2, or the 2 network being advertised with the /24. And as we can see, we have the 2 network /24, and we also have the /22. So again, that is how you use a leak map to filter routes. The leak map will allow you to send more specific routes along with your summary route to your routers. In this case, we had a /22 that we were sending to router 2, and we also permitted the 2 network from being sent as well with the leak map option. If we can ping, if we try to ping the other networks, you can see they are still reachable. With the leak map, we are allowed to do more filtering depending on what our network needs are. In this case, router 2 needed the 2 network, so we allowed the 2 network. But we don't have the 0, the 1, or the 3 network /24s. We don't have those in there, but they are still reachable. So what I'm going to show you next is on router 1, we are going to perform summarization to router 3 using a leak map. And router 3 is going to need the 3 network. What I'm going to show you is a problem that you could run into when trying to do this. If we go under the interface, which is to router 3 is serial 01, but as you remember, we have a point-to-point subinterface, so we'll do interface serial 01.13. And if we wanted to perform summarization to router 3, we do the IP summary address EIGRP 1. Say our task is from router 1 to router 3, they want us to summarize to a /22, and that is for the networks 0 through 3, just like we did to router 2. But in this case, they want us to use a leak map to allow the 3 network to come through and be seen as a /24 on router 3, but none of the other more specific /24 networks to be known are shown in the routing table. Easy enough. We just learn how to do that our task from router 1 to 2. So we go under the sub-interface here, we do the IP summary address EIGRP1 and put in our summary address, which is 192.168.0.0 with the /22 subnet mask. And now if I hit enter, if I go to router 3 and do a show IP route EIGRP, we see the /22 now on router 3. So all is good so far. Let's go ahead and create an ACL. We'll create a standard ACL named R1 to R3 leak as the ACL name. Then we're going to permit the 192.168.3.0 network with the /24 wildcard bit mask, because this is the network that we want to advertise to router 3. So we'll go ahead and permit that under the ACL. We'll create another route map. For the connection from router 1 to router 3, we will create the route map R1 to R3, and then under the route map we're going to match IP address, which is going to be calling the ACL R1 to R3 leak above. So anything that matches this will be permitted. Again, I guess I could have showed you this with the other route map. If I do a show route map, basically this route map is going to permit sequence 10, which is match ACL R1 to R2 leak. So in this case, the route map is called on to the leak map statement under our summary address command under the interface. So the leak map calls the route map is calling the ACL, and then the ACL is going to be permitting the more specific /24 network. In this case, from R1 to R3, if I do a show IP access lists, if I look at the R1 to R3, we are going to be permitting the 3 network through along with the /22 summary address. So let's go under interface serial 01.13, which is our point-to-point interface. If I do the IP summary address EIGRP1 with the IP and the subnet, and if I do a question mark, you see now that we don't have the leak map option, and this is where you could run into a problem where it's wanting you to create a leak map over a frame relay connection under the sub interface. So we don't have that option under the sub interface, so we have to be creative and find out another way in which we can perform this task, which in this case what we're going to have to do is we're going to use what's called a virtual template. And put in our summary with the leak map under the virtual template interface instead of using the point-to-point sub interface. So under the sub interface now, we're going to have to take off the IP address, which is 172.16.13.1. We'll also do a no frame relay interface delc 1 to 3. So now our point-to-point sub interface, if we look at it, it's pretty empty. We can go ahead and take this summary address command off too. So now the next thing we want to do is configure a virtual template. The way we're going to do this is by using the following command. What we need to do is go under the sub interface and specify the command frame relay interface delc. Then we're going to do delc 103. You see we have some more advanced options. We're going to use the PPP option. This will allow us to perform PPP encapsulation over our frame relay network, and then this is going to allow us to use the virtual template, which will allow us, under the virtual template interface, we're going to perform summarization with the Leak-map option. So again, the whole reason we're doing this is because the default frame relay configuration using point-to-point sub interfaces, the default option did not allow us to use a Leak-map under the summarization on the point-to-point interface within EIGRP. So what we need to do is create these virtual templates using PPP encapsulation over the frame relay network, which will allow us to use the Leak-map option. So we're going to do the frame relay interface delc 103 PPP, and then we're going to have an option for a virtual template interface. So we'll create the virtual template interface of 13. We'll go back and we will define this virtual template interface as well. So virtual template 13, we're just using this number to help us remember that that's the virtual template interface from 1 to 3. Now we can go under the interface of virtual template 13, and this is where we configure the IP address, which is 172.16.13.1 with a /24 subnet mask, and then we will do the frame relay. I'm sorry, no frame relay command under the virtual template interface. I'm sorry about that, don't know what I was thinking. Let's go to router 3 now and get it configured. We'll do a do show run interface serial 00.31. We'll get rid of the IP address, and we are going to take, let's go ahead and do that first. We'll go ahead and do a no. Actually, we need to go under the sub interface first. We'll do a no IP address. Then we are going to do a no frame relay interface delc 301. Then what we're going to do is we're going to put in the command that's going to call our virtual template interface, which is frame relay interface delc 301 using PPP encapsulation, and then we're going to put in virtual template and then our interface number for our virtual template, which is 13. Now if I go under interface, if I do a show IP EIGRP neighbors, is we don't have any neighbors running across from router 1 to 3 yet. What I need to do is go back under the virtual template interface which is virtual template 13, we need to configure our IP address of 172.16.13.3 with the /24 subnet mask. And now if I do a show IP EIGRP neighbors, doesn't look like I haven't formed a neighbor adjacency yet. Let's do a show IP route. And it doesn't look like I have any connections at all to router 1. If I do a show IP route on router 1, we can see that we have only the connection to router 2. Let's do a show run on router 1 and see and take a look. If I do a show IP interface brief, we can see that the virtual template is down. Let's go under the interface virtual template 13, and we'll do a no shut just to see if that helps out the case at all. As we can see, it is still down as well. So this is a good troubleshooting. This is a good time to troubleshoot. If I do a show IP EIGRP neighbors on router 1, we only have the neighbor adjacency to router 2. Looks like there's something that I'm missing between the link from router 1 to router 3. If I do a show frame relay map, we can see that we have the mapping in there. Serial 01, I have the frame relay interface delc 103 PPP virtual template 13. Under the virtual template 13 interface, I have the IP address, and under EIGRP I am advertising this. We are running EIGRP across that virtual template interface. And as we can see, if we do a show IP EIGRP neighbors, it's still only showing our connection to router 2. Okay, so I went ahead and paused it there. I went ahead and got the connection working. Didn't want to draw that out any longer. Now if I do a show IP EIGRP neighbors, you can see that we have the neighbor relationship from router 1 to router 3 now via the interface virtual, our virtual template interface. If I do a show IP EIGRP neighbors on router 3 as well, we have the neighbor adjacency to router 1. If I do a show run interface serial 00 dot 3 to 1, we see that we have the frame relay interface delc 301 PPP virtual template 13. If we do a show run on that interface virtual template 13, the frame relay command under the subinterface, the frame relay interface subinterface has the virtual template interface assigned to it, and then the virtual template interface has the IP address under it. So now you can see that we are routing for the 13.3 network under show IP protocols, which is right, because that's the EIGRP network command that we put on there. What we saw just a minute ago is that the virtual interface was not up, the virtual template interface. The virtual access interface was actually down. I think what was wrong in that scenario is we went under the sub interfaces on router 1 and 3. We took off the IP addresses, and we also took off the frame relay interface delc command, and then we added the other frame relay delc command specifying PPP and the virtual template. What I did this time was I took all the configuration out, I made sure the EIGRP connection was up under the frame relay interface. I took off the IP address, then I went back in, created the virtual template interface, and then the command under the sub interface. So the only thing different this time, we did not do the no frame relay interface delc 301. Don't know why it worked or not. I've never seen that happen before. So anyway, if you have problems with your virtual template, your virtual access interface is not coming up, try to delete your interfaces and start from scratch again. This time it came up with no problems, so I'm not quite sure, but I know that we have it working now. If I do a show IP route to EIGRP, we have all of the networks now showing up on R3 that originated from router 1. So again, the whole reason that we created the virtual template interface was because we could not summarize using a leak map over the point-to-point sub interface from router 1 to router 3. So what we had to do is create the virtual template interface and specify under our frame relay connection we needed to call PPP virtual template interface, and then under the virtual template interface we have our IP addressing. So now if we go ahead and try to summarize, if I do the go under the interface virtual template, which is 13, and I do the command now for the summary address, IP summary address EIGRP for AS1, then we're going to put in our summary route, which is 192.168.0.0 with the /22 subnet mask. If I do a space question mark, now we can see the leak map option. So we'll go ahead and do leak map, and then the word, which is going to call our route map. And our route map is going to be R1 to R3, and that should be it. So now if I go to router 3 and do a show IP route EIGRP, we can see now that we only have 2 routes instead of 4 routes before. We have our more specific /24 that we are leaking into the update to router 3, which is 3.0. Then we have the /22 as well, the summary route. I can also ping just to make sure I have connectivity to the other subnets, the 2 network, the 1 network, and the 0 network. So it has worked on R1. If we do a show route map, we created a route map that calls an ACL, which is R1 to R3 leak, which under this ACL we are permitting the 3 network, and that is it. And then under the IP summary address EIGRP command under the virtual template interface, remember this time we did not do it under the sub interface, we did this under the virtual template interface. We were then able to specify the leak map option, and then under the leak map after that we called the route map, in which the route map calls the ACL, which permits D3 network. So it's a lot of work to do, but that is how you perform EIGRP summarization and EIGRP summarization using leak maps over both a standard serial interface and also a sub interface. We went and looked at how you did that under the sub interface by doing PPP encapsulation using a virtual template interface. So kind of tedious, a lot of commands that we had to do, but it is very important that you understand these techniques because you can be and you may be tasked for doing something like this at some point. If we do a show IP EIGRP neighbors, we have a neighbor relationship both with router 2 and router 3. The last thing I wanted to do in this lab is to show you how to inject a default route into the EIGRP domain. We can do this by using the summary address command. We'll create an interface loopback 10. We'll do the 192.168.10.1 with the /24 subnet mask. Now we're not going to advertise this into the EIGRP domain, but what I'm going to show you, if we go to the connection to router 2, which is interface serial 00, I'll do the command IP summary address EIGRP 1. Then here we're going to do all zeros, so 0.0.0.0 with a 0.0.0.0, kind of like a default route. And then we'll go ahead and hit enter. Now what we're going to see if we go to router 2, if I do a show IP route on router 2, now we have the gateway of last resort set, which is to router 1, which is 12.1 for network 0.0.0.0, and we have the EIGRP default route now in the routing table. So anything that we don't know how to get to via the routing table, it's going to send it out this default route towards router 1. Again, router 1 is advertising a default route to router 2. That's why router 2 sees the default route coming from router 1. If we go back to router 1 and do a show IP route, it has its gateway last resort set, and it has the null 0 route now in router 1. So router 1 has to have the most consistent routing table in this instance, or you're going to create problems for your spoke routers. Because if router 1 does not know how to get to it via EIGRP, it's going to black hole this traffic. So from router 2's perspective, it's seeing router 1 as the gateway of last resort. So as you can see in my routing table, I don't have a connection to the 10 network. But what I'm going to prove to you and show you guys is that the traffic flow should go out, and I still should have connectivity to router 1's 10 network because of the default route that we just put in to router 2, or injected into router 2 from router 1. If I go ahead and try to ping this IP address, which is 10.1, as you can see, we are successful. If I do a debug IP packet and do a ping, if I do a show log, we can see the source is the 10.1 and the destination is 12.2, which is router 2's IP to get to router 1. Again, when we do that ping, we're using our exit interface as serial 00, which is 12.2. So now if we go to router 1 and do a debug IP packet, let's go back to router 2 if we do a ping. If I do a show log on router 1, you see the source, it's routing just fine. It's going to the 10 network with 192.168.10.1, which is with the destination of 12.2, which it knows how to get through to router 2. So what we're seeing is if we do a show IP route, we have a default route pointed towards router 1. So the source of this ping is 172.16.12.2, which is router 2's serial 00 interface, which is to router 1, the exit interface, and the destination is the 10.1, which it doesn't know how to get to, so it uses the default route to go out to router 1. And if we look at router 1's routing table, it knows how to get to the 10 network, and then it sends the echo replies back to router 2. It sees the source of those pings was the 12.2 IP, which is under its directly connected network to serial 00, which is the directly connected interface to router 2. And that is why we have connectivity. So that is one way to perform and inject a default route into your EIGRP domain. If we wanted to do that to router 1 to router 3, again we'll go under the virtual template interface, and we'll do the command IP summary address EIGRP1, and then we'll do all zeros, 0.0.0.0, 0.0.0.0. Now if we go back to router 3 and do a show IP route, we can see now that we have the default route injected into my EIGRP domain. So now if I try to ping something that is not in router 3's routing table, which is again the 10 network we can use, which is loopback 10 on router 1, I'm sorry, not 0, 10.1, I'm sorry, not 193. It would help if we had the right IP address, 192.168.10.1, and now as you can see we have connectivity once we put in the right IP address. Again, the traffic flow, it's going out the default route via the virtual access interface. So if I do a show IP interface brief, the virtual access interface is the 13.3, which is the connection to router 1. If we do look on router 1, the virtual access 1 interface has got the 13.1. And And if I look at the routing table, I know how to get to the 10 network because it's directly connected to loopback 10. And then the source of the ping, which is 13.3, which I know how to get to on router 1 via its virtual access 1 interface. So my echo replies are now making it back to router 3 successfully. So again, that's how you perform basic EIGRP using that's how you perform EIGRP summarization and default, and how you inject a default route into EIGRP. We looked at taking multiple networks and summarizing them into one network. We looked at the concept of using leak-maps, which allowed us to send along with the summary route a more specific network. In this case, on router 2, we leaked the 2 network, and on router 3, we leaked the 3 network. And then the last thing we did was inject a default route into EIGRP using the IP summary address command as well. So I want to thank you guys for sticking with me in this long video. I hope you guys learned a lot, and I hope to see you guys in the next video. Thank you.